Today's talk, I'm going to be giving you a guide and a shared vision on how AI can support the job of researchers, whether it's a team or whether you're a researcher team of one. I'll walk you through what we've learned so far, give you a guide to how to develop your own with low-code or no-code models that can enable and empower the research job function, and how to build these tools yourself. We'll deep dive into one particular example, and we'll talk about the problems that we built for it to solve, and how we built them and how we trained them to those specific needs and patterns and standards. And then we'll talk a little bit about how you can do this yourself at home. So what we've learned so far. So I just want to give a heads up that we don't have all the answers. This is actually very much a work in progress project that we are working on right now as we speak. So this is something that, you know, we're not completely done with. We haven't fully launched this to the level of completion, but I thought it would be really helpful to just share some of the things that we're learning. So they're very preliminary findings, because I think it might be helpful to this community so that you can go out and do it yourself. So these are just some early things that we've observed. I believe there is an important place for humans in a future powered by AI. Humans play a critical role in the development of an AI-powered world that is good for humanity. Researchers have a powerful opportunity to shape the future of this technology, but we can only do so by exploring this space as we would any other research space. So there are a few things that we believe humans are still better at least for now. Deriving real insights and findings, so making meaning from that data. Right now, the tools at least that we're using, we're not finding that the AI is able to really do this. Take that sort of messy middle, some of those messiness, those things that you observe in human behavior and attitudes, making sense of that, giving it meaning, giving it story, and being able to tell that story to your stakeholders. We haven't found that the AI can really replace that. The humans are still better at that. We're also finding that the AI, even though it does a really great job at scanning, it doesn't really do a good job of what I call reading between the lines, knowing what's not being said, what's the unspoken thing that we're observing. So I think a part of a good qualitative researcher is being able to infer and understand that subtext. Designing research studies, we found that being able to understand what problems to solve, which methodologies to apply, how to mix those methods together to get the outcome that you need, these are still things that should be human-led. Conducting qualitative research, understanding that nuance, at least leading it. Managing stakeholder expectations. This is still something that I think is really important for we as human researchers to really get alignment from your stakeholders, make sure that you're prioritizing the right problems to solve at the right moment. This is something that we still find that humans are better at. And then telling that story, telling the story in the right context. We know that AI and generative AI can tell stories, but can it tell the story that we want it to tell in the way that we need to, in the right context? However, our agents and our AI agents are really good at some other things. Driving action to a specific task or goal or objective relentlessly. It's really important to have a very clear objective when you're building your AI agents. I'll be talking about this repeatedly throughout this talk, but it doesn't really make sense to start building an agent if you don't have this clarity. If you don't have certain things and processes defined, it'll just help you get to the wrong place faster. Processing large amounts of unstructured data quickly. Pages and pages of transcripts, reports, recordings, things like that. It can get through that in a matter of seconds, which would take a human several weeks, if not days. We found that it's really good at taking a first pass at detecting major themes. So I'll talk a little bit about this, where we have a large set of unstructured data, some transcripts, some surveys. Now, while it can't fully do all the analysis and synthesis on its own, it's really good at doing that first pass. So having it take a quick run through the data, clustering some major themes, but you still need to do the work yourself to analyze it and make sure that you're refining it. Retrieving information from multiple data sets, formats, and most importantly, it's really great at being in multiple places simultaneously, which we humans cannot be. So this is where we're using our AI agents today to support us in these various phases. So think of them as hyper-intelligent interns. They can work really, really fast and get you what you need, but they still need a lot of guidance and training and feedback. It's very, very important. You can't just let them run off on their own. They'll sometimes come back with things that are close to what you want, but you still need to tweak it a little bit. At least that's what we're finding. So right now, in planning or in design, we can use what we're calling Molly, who is our research assistant. So she's kind of like a little editor that can kind of sit on your shoulder and check your work. So for example, you can program Molly to vet or test your questions for bias. Take a look at your survey questions. Are these right? Do they meet the standards that you've programmed into her? Synthesis and analysis, we're finding that this is a really great area to employ agents. They can scan transcripts and survey results, help you cluster and theme. So Audrus is our interview analyzer that we've built, and Marco is our survey coder. Document and capture. I know this is not necessarily the sexiest place in research, but I find to be incredibly important. Being able to document, capture your findings, capture them in your research repository is absolutely crucial. So that's an area where we also use Molly, who will take a look at our summary of findings, our abstracts, and make sure that they're up to the right standards. So she can give them a little bit of a scoring, and you can make sure that you go back and have those researchers potentially rewrite certain areas. And last but not least, and I'll talk a little bit about this agent a lot more in our example, is distribute and sharing findings and insights to a larger and larger organization. Our team at Autodesk, we are a small but mighty team. We cover an increasingly large amount of teams, product managers, engineers, marketers, and it's really difficult for us to be in all those places, being able to answer their questions in the moments they need the most. So I think this is one area that there is a very straightforward way that we can develop a way to solve this problem. A few other things that we've learned about our agents. As I said before, they need a very clear objective or purpose. You need to understand what they're trying to do before you start building them. There's a lot of great tools out there that you can chain together, but if you don't have a good understanding of what you're trying to solve or what you're trying to accomplish, it tends to get pretty muddled. It doesn't create meaning on its own. Humans still need to do that. So there's that little nuance, that little sort of in-between that I think humans are still really good at. I don't believe this replaces our doing our own research. I see this as a way to augment and enhance and support and empower the researchers and the research that they're doing. We've also found that the data should be themed or clustered. So we affectionately call these data clusters our research brains. So they're sort of like our institutional memory. We've done a lot of work. I hate to see good work go to waste, and oftentimes we get asked the same questions over and over again, but in different ways. So this is a great way for us to extend that institutional memory and be able to find it in a matter of seconds. It also is not great at that sort of general intelligence, so this is another reason why clustering it based off of the problem or the objective that you've set out for yourself really is what works best. I think it's best to start small with contained experiments and then test and iterate. So before you release it out into the wild to all of your stakeholders, to your entire organization, it's probably a good idea to kind of keep it as a contained experiment. Because sometimes it always, 80% of the time it gets it right, sort of 80-20. That last 20%, sometimes it will bring back something that's a bit unexpected or a little bit strange. So there are some examples where we've had it theme or cluster a particular interview, And while 4 out of the 5 points are aligned with what we would have done as a human, sometimes that last point they bring back is a little bit strange. It may take it out of context. It doesn't really understand the nature of the conversation in the same way that a human would. And so sometimes it brings back some things that aren't necessarily quite right. So that's why it's still really important, I think, to run, especially in the beginning, your studies in parallel. A human-led and then an AI-led process. And that way you can compare and contrast and make sure that it's bringing back what you would expect it to. And if it doesn't, that means you need to go back and tweak your data set or tweak the model. And last but not least, it doesn't get sarcasm. It doesn't get subtext. It doesn't always get humor. It's a very literal thing. So subtext in a conversation, we as humans, we know this. There's body language, there's posture, there's the things that are not said in between those lines. It does not get any of that. So just be aware. It comes back and it's very, very confident as well. So it sometimes feels like truth, but that's why we have to test it and run those things in parallel. So how we trained agents to support our work. So this is what we did. I'm not saying this is going to be right for everyone. I do recognize that at Autodesk, we are very fortunate and we had a lot of those basic ingredients that made this possible for us to actually dig into this. But I wanted to share it because I think there's some lessons that can be learned from it. So we started by identifying what were those top 3 problems that we were really looking to solve. And I think these problems are issues that tend to plague a lot of researchers and research teams. For one, human inconsistency and our bias. We as humans, we have different experience levels, we have different skills, we work at different speeds, we also bring our own biases, we bring our own baggage. We're humans. So sometimes that can actually interfere with doing studies, especially at scale. Time and resources needed for coding unstructured data. So in this graphic here, 80% of an organization's data is unstructured, but only 10% of that data gets analyzed. This really allows for us to unlock the potential and the insights buried deep in that data that's not analyzed. And this does it in a way that's much faster and more efficient than what humans could possibly do. And last but not least, surfacing insights. I don't know about you, but we have the challenge of sometimes we do really great work. We have great learnings, great insights, but it's really hard to know. We tend to go door to door like, hey, do you want to read this report? Or here's some things for you. We're trying to make it more digestible for you. And they're not ready, if they're not ready to hear it, or in the middle of a sprint, or that's not the problem they're looking to solve, it just becomes a very tiresome activity. And it's hard to be in all those places at once. It's hard to know what are those questions that they're asking themselves, and how can I know when they're asking it and be there to give them those answers. So that's another area that we're finding has been a really big challenge for us, at least at Autodesk, and being able to really scale sharing that learning as the organization gets larger and larger and runs faster and faster. So how do we do this? Well, we use a platform called Relevance AI. They're a relatively young company based out of Australia. And this is really helpful for us because we are not a team of programmers. I'm a researcher. I'm not a technical person. But I sort of see this as a platform that gives you sort of pre-baked, semi-baked models for you. They're pre-trained. They give you access to a variety of different models that are already ready to go and ready to be trained and chained together in the way that you need. So here on this graphic on the right, it gives you access to GPT-4, to Claude, to Palm. It specializes in extracting information and querying knowledge bases in any format that you want. So basically, we as researchers can easily string together these tools and create these agents. But the tools are strung together based off of what each of those agents are trying to accomplish. One note of warning, this platform doesn't do a few things. It doesn't do quantitative. It doesn't visualize data. It's not a good dashboard. It does not replace the need for a research repository or a knowledge base. It doesn't do any of those things. It's not a prediction model. So it's not something that you can do or use to try and predict or forecast in the future. It's really good at retrieving information that already exists. And it doesn't learn automatically. There are some quirks and challenges in how you update its brain, but it doesn't do it automatically. But there are some ways that you can get around that to make sure that the brain is up to date with the most relevant information. But some of that still needs to be manual. So with these agents, we'll go into one specific example. So let's talk about Aska. Aska is a name that we gave our insights finder. So she helps surface insights and learnings at scale. Now, I wanted to go through Aska because while she is the least technical of the agents, some of the agents you'll see there are a series of 5 or 6 different little tools that are chained together. All Aska is essentially a GPT layer or retrieval layer that sits on top of our research knowledge base, or what we affectionately call our brains. So the Autodesk researchers will still conduct their studies, input them into our knowledge or repository, but this allows for you to have this open prompt where you can type any question that you want, and it will retrieve that information based off of that knowledge base in a conversational way. So before we went into using Relevance AI, one thing you should know about our team is we went through a lot of the work to create a really clean, high-quality, up-to-date research repository. It's not sexy work, but it is incredibly important, and it allowed for us to do this very easily. And it was a lot of work to get through that, but the problem was the search function is very text-based or keyword-based. So you kind of had to know what you're looking for to enable to get the right studies to pull up. This kind of took it a little bit further. It allows for us to, or anyone, to be able to type in a question in a natural way as you would in a conversation, and it would bring up an answer in a very conversational way. Right now, we've only released it to our Autodesk researchers, and that's because it's not quite ready. There are a few tweaks, there's a few things, a few glitches that we still need to work out. So, but once we start, the future vision here is for this to be available to all of our stakeholders and decision makers. So instead of making them come to us for the information, we can embed essentially an open prompt bar in the places where they're already working. Whether that's Figma, Jira, a wiki page, it brings the answers to them so that in those moments when they're in their sprint cycles, they can type in a question. We often get a question quite a bit. What do we know about fill in the blank? What do we know about this particular thing? It can bring back all the research that's been done to date. One of the most important, and I'll keep saying this again and again, the most important ingredient to Aska is that database, is that repository. And what we did here is we created a structure in our own wiki, and this is already part of our process. And we would tag certain elements of it when it was ready. So certain things maybe needed to be updated when a project was complete and ready for ingestion. And we often would use Molly to rank or score those cards or those archives when they were ready to be ingested into the brain. So I want to give you a quick screenshot of what it looks like. So just as a heads up, this is not the real agent. I'm not going to show you our actual research repository. But what we did is we created sort of a fake Aska on a fake library. So Autodesk, we have a design and make report that we publish every year that's publicly available on our website. So we use that as sort of a fake library. So the first thing you can do here is you can ask the agent, what do you do? And in here you can program in the script that you want her to say. And if she can't find anything, like let's say they ask kind of a strange question, or maybe there's just no data on that particular question, she can direct that stakeholder, that person, to fill out an intake form or request new research. And it's a great way to understand where are the gaps in your research database or your research knowledge base. Here's a screenshot where you say, let's say I want you to summarize top 5 research findings from 2024. This is, again, made up. And she will return a summary. And oftentimes, you can program the agents to return it in a certain format. So one example is we like to have a brief overview, main findings, and of course, just like any good research paper, you want to cite your sources. So a link to that research page, however you want to store it. And then this one, I just wanted to give I know it's kind of hard to read, but this is just a screenshot of just showing the platform and how you don't really need to know how to code to be able to use it. So you'll see here, there's some natural language. You can just kind of put in your instructions. There are settings. You can select the model that you want to use, depending on what you're trying to do. So if you want to select GPT-4, for example, the triggers and the integration, and tagging the data set as well sometimes makes it a little bit more efficient. So what is the opportunity for us as a community? Imagine having a mini researcher embedded in hundreds of teams that can query your research in the moments they need to make those decisions, in the moments that they need them most. Imagine being able to focus on conducting the research itself rather than going from team to team trying to find someone to read your research reports. Imagine being able to accelerate the sharing of your research and scaling the breadth and depth of its impact with just a small research team. So how can you do this for yourself? Like making a meatloaf or a cake, you need your basic ingredients. It's really important to have those set up before. So, in my opinion, these ingredients are threefold. Data. Data is very important, that knowledge base. Creating a repository of research or that knowledge base is critical to being able to create something like ASCA. But it's also really good practice. It's helped us reduce the amount of redundant work. It helps us reuse research. It helps us be more efficient and helps grow our body of knowledge as an institution. Platform. You can use Relevance AI. I think there are a lot of other tools out there. But it's, I think, also really important to know your organization's position on AI. We're very fortunate that Autodesk is very AI forward. We're exploring ways to leverage AI and generative AI to enhance design workflows that are high risk and highly complex. So we've had an AI governance process in place, and I was able to get leadership buy-in to get the budget to do a proof of concept for the first 3 months. And then last but not least, people. People are a really important ingredient. Whether you're a research team of 1 or a research team of 100, it's really important to understand, for 1, what are your goals? 2, create a program around it, just like you would anything else. Make sure you identify who's a part of that program, who's leading it, who's on that team. Set some time frames and some goals, and select your tools. And of course, I want to give a shout out to my research team that's here. There's a few of us here today. I want to specifically give a shout out to a couple people. I said we a lot, and I can't take credit for doing all of this. It was a team effort. Judy Bain is one of my principal researchers. She's the one who came up with this idea and found Relevance AI. And then I got the budget to make it happen. I tapped our program manager, Manuela Scala, to lead this program. She'd never done anything with AI before, but really jumped in, rolled it up her sleeves, and started building these on her own. And of course, the other team members that we've been testing and iterating these models. Lars Jensen is here today, and he's really been super critical in building out that knowledge base that I kept talking about. We couldn't have done it without them. So I just wanted to say thank you and open it up for questions.